The idea is we're getting steadily closer. Now I'm going to do the same problem two different ways. One of the ways I'm going to approach it is I'm going to say, hey, let's leave. Hey, Jeremy?
Yeah.
I just said it's very important to hear this part.
Okay.
I don't know what the two of you are doing, but it needs to be with me.
Okay.
Thanks. What we are doing right now is we're doing it numerically. So I'm going to approach this two different ways. And if you look down in the next 10 minutes, you're going to look back up and have no idea what just happened. So if you're going to check your cell phone, you might as well take a nap. What's about to happen is we are going to develop a general way to do all of these slopes in a much more efficient way. But to do that, we got to go through doing the problem in a general form. So I'm going to start off by doing, just like we've been doing, find the slope the way we're doing it. But on the right-hand side, at the same time, I'm going to be doing, I'm going to leave the x's as x's and do a generalized form of the same thing. Does that make sense? So here I go. The problem at hand is, the first problem up there, the function we're going to deal with is f of x, excellent, f of x equals x squared plus 2. And I want to find the slope at the point 0, comma, what would it be when I put a 0 in there? 2. So I put a 0 in there. Point 0, 2 is the one I care about. Does that make sense? Now over here, I'm going to generalize it. So when I generalize it, I'm going to go f of x equals x squared plus 2. That's the same thing. But the point I'm going to solve for is not 0. The point I'm going to solve for is x. Any x. And what does that make my slope? What makes my y value? It makes my y value f of x, right? Whatever that value would be. So far with me? Chris, you with me? Okay. So all I've said so far is that I'm going to try to find the point at 0, 2. And in generalized land, I'm going to try to find the point at the point x, whatever x would be if I plugged it in. Right? That's how we found the 2, right? We plugged it in. Okay, so what is the next step? And I'm going to go a little slower than we've been going. I need to pick a point, what? Close to 0, 2. So the point I'm going to pick is just a little bit more than 0. So what would that be? Whoops, I want red pen over here. So I want to pick the point 0, 0, 0, 0, 1. Fair enough? And when I plug that in, somebody plug that in for me. Says 2. Okay, your calculator is rounded to 2.
It's
hopefully it's got a little number on the end.
It's
it was 2.
It was
point
9 zeros.
It's
1, 2, 3, 4, 5, 6, 7, 8, 9 zeros.
Yeah.
Yes.
And a 1. Oh, no, is it a 1? Yes, it's a 1.
Yeah, your calculator doesn't actually round
Yeah, but
it.
you gotta
It just it abbreviates
All right.
it because it doesn't want to display that much.
Right. So we're good there. That make sense? Okay. So over here, I'm going to write x, right? Whatever the value would be, we're going to plug in, and a little bit more than x. Now here's where me and AP Central and the rest of the calculus world separate ourselves. But I'm going to do it the way they do it because it's the way you're going to see it. And that is, how am I going to write a little bit more than x? Be nice to pick any letter. They didn't do that. They chose a little bit more than x. That's what this means. A little bit more. That's what that means. A little bit more. Comma. What would that make? How would I figure out what my function would be at that little bit more? How would I write that?
F
of x a little bit more.
f of x plus a little bit more.
Okay.
How would you write it? Why is this different than AP Central? Or yours?
I would use H. I'd use an L. I'd use a letter. Because you guys get really hung up. Delta X. Delta X is weird. Okay, L could be a little bit more, couldn't it? Wouldn't that be fun?
Yes, change
They
it.
use delta X. And since they use delta X, I need to see it because that's what you're going to see. With me so far? All right. What's the next step over here?
You subtract that.
I'm going to do slope, right? So I go slope. I'm going to do this. 2.0000. Oh, man, I'm not in red. Hold on. A little red time, though. That's no.
Isn't it 2
Okay,
minus?
so slope, slope would be 2.0000000123456789 minus 2, right? All over 0.00001 minus 0.
This is so weird.
Would it not?
Oh crap. Oh no, I was gonna. Oh, it's gonna go.
So what's the slope over here going to be?
F of x plus delta x.
Walker's going to tell us what it is. So the slope over here is going to be
F of x
f of x
plus delta
x
minus
minus
f of x. And then x
all
plus,
over
x plus delta
x plus delta x
minus x.
minus x.
Oh my god.
Oh yeah.
That's horrible.
Oh yeah.
Why would we do this? I'm out of room now.
Now over here we're going to solve it. Right? We're going to solve it because we got numbers. We're going to solve this thing. And if I solve this thing, I get 0.000000123456789 1 over 0.00001. And my slope would be roughly 0.00001. Fair enough? And we would guess we're approaching what number, Brandon?
0.
0. How would I check to see if that was the case?
Go closer.
I'd pick a limit, and I get closer and closer, would I not? Fair enough. So I take the limit as I get closer and closer. So the way to find the slope would be to take the limit as delta x approaches, what is delta x approaching? What do we want delta x to become closer and closer to? 0. Excellent, because we want it to be closer and closer to nothing, right? Closer and closer to nothing. Of f of x plus delta x minus f of x all over, hey, look at this bottom. I've got an x, I've got a minus delta x. Sorry, I got an x plus delta x minus x. Can I simplify this?
Yes.
Delta x, thank you. Now, at the middle of your page somewhere, it says write down the formal definition of a derivative. That's it.
You have to remember this?
Yes.
Oh, crap. It's quadratic formula all over again.
Well, it should be on the right-hand side because you did what you're supposed to do. But down below it says, does it say new formula? Yeah. Oh, sorry, my bad. New formula, put that down. All right, so you have that as a definition, right? You ready? Now, since I have this definition, let me do the exact same problem a different way. Fair enough? Let's do it a different way. So there's my thing. So here we go. So I'm going to take the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. With me so far? I just wrote down the definition. That's going to be my starting point for the problem for the rest of this way. The function I'm interested in is what? x squared plus, was it 2? Yes, thank you. Okay. So here I go. Going to use this definition now. I'm ready to go. Are we with me? So I take the limit as delta x approaches 0 of f, where we're replacing everywhere I place x with x plus delta x, right? So I'm going to go x plus delta x squared plus 2, pausing there. Because all I did is I took the function, which would normally be x, and I replaced it with x squared plus 2. Has everybody got that? Be the fastest that's ever happened if everybody's got it. Okay? So the function, what do we do when we have a function like this? We just replace it with, right? Oh, wait, did I do that wrong? No, I did right. Okay, so everywhere you see an x, I replace it with what's inside the parentheses, right? So it's f of 2, I just put a 2 in there, right? So I basically take the x plus delta x and replace the x on the function, right?
So then you put the -2 on the outside.
Oh.
So basically, hold on. Let me reset this maybe. No, I messed this up so bad. You're going to look at the function. It's going to be, this is your x, right? Plus 2 would be the normal way I write the function, right? But instead of x, I'm going to write in x plus delta x.
What are you going to do with the 2 though when it comes to the negative f of x?
I'm going to do the same thing. I'm going to go over here. I'm going to go, this is going to be minus x squared plus 2. Agreed?
Oh, okay. See, I
Everybody with me?
thought you were just done.
Oh, no, I wasn't done.
There's no more.
Sorry.
Wait.
Delta x. Pausing there. So this is the function with x plus delta x in it. And this is the function with just x in it.
Wait. Why is there 2? Where did the 2 come from in the middle?
It's a 2 here.
Yeah, but
So this is the function where we replace the x squared with x plus delta x.
okay.
And there's a plus 2 on the end still. That's still there. Everywhere I see an x, I replace it with x plus delta x.
Oh god.
Right?
Okay.
Now, how do I take a limit? You know how to do this in this last chapter. This is why we did it last chapter. We plug in a 0, and guess what's going to happen every single time? So you might want to not even bother with it. You get 0 over 0. How do I deal with 0 over 0?
Factor.
I factor by simplifying first, right? So let's simplify the heck of this thing. How do I simplify something in parentheses with a square on the outside? I FOIL it. So I got x squared plus 2 delta x x plus delta x squared plus 2. Now I'm going to put the minus through over here. Minus x squared minus 2 all over delta x. So I FOILed the first part, added the 2, and then distribute the minus through. I'm simplifying, right?
This is horrible.
But it gets much better in a moment. How does it get much better? Anybody see anything I can cancel out? I can cancel out this one. I can cancel out these ones, right?
Oh, so it actually is getting better.
So then I'm going to put a limit in. Limit. Remember, I haven't taken the limit yet. Of 2 delta x x plus delta x squared all over delta x.
You can divide delta x through, can't you?
That's the next thing, right? Can I get a delta x out of everything? Then let's do that, right? Now I'm going fast there. That was a fast step because 3 people said, yeah, we could do that. Ready? So I do that. I get the limit as delta x approaches 0 of 2x plus, there's still a delta x there, right? Okay, now that I've canceled something out, what do?
You
Plug in the 0. So I plug in the 0 and I get
point. But I don't really understand.
2x.
Wait, what? How'd you get that? Oh,
Well, you said plug in the 0. I plugged in the 0. What is it? Delta x. So I got 2x.
oh, okay. Yeah,
Agreed?
I was bad.
30 seconds.
Yeah, well, the rest of them are happy trails. Now,
How did you get from yeah.
I divided delta x out of everything.
Oh, okay.
Right? Top and bottom, right? Delta x is in everything, so I can divide it out. Which is what we're always trying to do. Right? We're trying to cancel out something. I cancel out the delta x. I get to here. Now I just put the delta x in there. Fair enough? Okay. We're going to